Hi guys, so this is section 5.3. In the last lesson, you did like an intro of what graphs of radical functions looked like. So we're going to take a further look into graphing radical functions and transformations and kind of a whole bunch of things that we've kind of already talked about this year already, but just applying them to a different parent function. This parent function is radical functions. So the first thing that we're going to do here is make sure that we can graph square root and cube root functions and talk about their domain and ranges. So hopefully when you did the intro activity last lesson, you discovered that when we are graphing a square root function, this is the square root of x minus 7, it gives us this like right wing shaped graph, and that's kind of how I refer to it, just right wing. Anytime, kind of honestly looks like the square root shape, right? The square root gives us just this right wing shape of a graph. Just like transformations with quadratics, with polynomials, with everything that we've really talked about, when I have a number on the inside of a parent function, that minus 7 is considered on the inside, which direction does it move the graph? It moves it to the right 7. Awesome. So then I'm going to take my graph, and it's a very rough sketch, but then I'm going to just make this right wing shape. Probably shouldn't be right on top of the other one, but it's the best that I can do in a quarantine. Anyway, so that's my square root of x minus 7 graph. That's in black there, shifted to the right 7 units. So let's talk about the domain and range. So we should remember domain is about all of the x values, right? So all of the possible x values. Notice it starts right here. We're going to base it off the black one that we just drew. It starts right here. So what's the smallest possible x value that will be used on this radical shaped graph? 7, right? It's never going to touch over here. It starts at 7 and goes towards infinity. So that is why my domain is 7 to infinity. Range, we know we look at the y values. The smallest y value is at 0, right? It never goes to negative numbers. So it's going to go from 0 all the way to infinity. Okay, let's take a look, I believe, at cube roots. Okay, the cube root of x plus 3. In that last lesson, you should have discovered that this squiggle snake-shaped graph is the shape of a cube root of x. Okay, that's the cube root of x parent function. We should remember that when we see plus 3 or a number on the outside, we should be able to understand and visualize this is outside and this is considered inside the parent function. So when I'm outside, then that means I shift the graph up 3 units. So I'm just going to take this center point and 1, 2, 3, move it up. Oh, this will be tricky. Something like this. Pretend it goes through, up 3, squiggly line, just like that. And that's the graph of the cube root of x plus 3. The domain and range, think about domain is all these x values. I have arrows on both sides of this graph, meaning that my domain is going to hit every possible x value, negative infinity to infinity. My range is the same thing. It's going to not only go outwards, but down, right? Outwards and up. So my range is also negative infinity to infinity. Okay, you guys are going to practice some of this in the practice section. You'll do some try-its. Let's take a look at the concept of the parent function of a radical function. Okay, so really, this is all the different numbers that can go to the parent function, the square root of x or the nth root of x. That's going to either move it vertically, horizontally, or vertical stretches and compressions. We're not going to be graphing them with vertical stretches and compressions, but we should be able to identify vertical stretches and compressions. A vertical stretch and compression doesn't impact the domain or range. It just kind of changes the amplitude or the slope of the shape of the graph. But we should be able to identify when that a is greater than 1, it's a vertical stretch, and when it's a fraction or a decimal between 0 and 1, it's called a vertical compression. and it compresses the graph in a vertical way. H we know moves it horizontally. Because I'm moving horizontally, impacting it horizontally, that means it's impacting my domain, right? It makes sense. Horizontal, the x values. Vertical translation is that K we know moves it up or down. Makes sense that it's going to impact my range. So let's do this example. And it says something like this. What transformations occur on this graph? And we're also going to take a look at the domain and range. So I believe we're going to graph it. Here is my parent function of the square root of x. I see plus 3, right? I know plus 3 moves it to the left 3, so I'm kind of now over here. And now I see plus 5, which means it moves it up 5. So now I kind of make both of those happen. I moved it to the left 3, up 5. And it's a vertical stretch, which means it just has more, see how it's steeper, right? There's a bigger curve to it versus if there wasn't a vertical stretch. So I just listed 3 transformations: vertical stretch, left 3, opposite of what we think, and up 5. So now let's talk about our domain and range. A little bit different. So my domain starts here, that x value, right? It moved it to the -3, so my domain is going to be -3 to infinity, starts at -3, goes forever to the right, and my range, look at where I'm starting on the y-axis, nothing, nothing, nothing until I get to 5. My range will be 5 to infinity. Okay? Notice that too, that vertical stretch, it didn't have any impact on my graph at all. Or it did have an impact on my graph, but it didn't impact my domain or range. Okay? And that's the second example in this section. Let's watch the next video to do the last example. There's just one more short example to go through. Awesome job, guys.